So now for example 3, we have to find all 6 of our trigonometric ratios for the given triangle. So make sure you have all 3 sides. So first, I see here's my reference angle theta, and then I'm just going to label this. Here's my opposite side from theta, my adjacent side from theta, and my hypotenuse. So as I look here, I don't have all 3 sides, so I'm going to have to use the Pythagorean theorem to solve. So in order to solve for that hypotenuse, I would have 10 squared plus 24 squared is going to equal c squared. Again, here's a, b, and then c. So I need to solve for what the length of this side is. So I'm going to simplify 10 squared plus 24 squared, and I'm going to use technology. So 10 squared plus 24 squared gives me 676. So 676 is equal to c squared. And then I'm going to take the square root to figure out what is c. And I got 26. So I'm going to put 26 in there. And now what I'm going to do is I need to figure out, well, what is my ratios here, or what are my ratios? So the sign again, I remember, so I just put up here, opposite over hypotenuse. So from theta, the opposite is 24 over the hypotenuse is 26. So we have 24 over 26. And then I just have to reduce that. Well, I notice I can divide the numerator and the denominator by 2. So 24 divided by 2 is 12. 26 divided by 2 is 13. So that ratio is 12/13. And then here, the cosine of theta. Well, cosine, so, and then ca, I put over here, adjacent over hypotenuse. I do that in my head every time, but I wanted to write that out for you. It helps me, so I'm sure it'll help you guys as well. So from theta, I have the adjacent and the hypotenuse. So those ratios are 10 over 26. And then I notice I can divide the numerator and the denominator by 2. So that's going to give me 5 over 13 for the reduced ratio. And then lastly, for the tangent of theta, if I'm doing that, so, ca, and then toa, so opposite over adjacent. And looking at theta, the opposite is 24 over 10. And then I can divide the numerator and the denominator by 2 and get 12 over 5, leaving that as a fraction. So now for my cosecant, what I'm going to do, again, I use Cho-Shikow. So cosecant, Cho, so hypotenuse over opposite. So here we have 26 over 24. And then to simplify that again, that's going to divide by 2, and you get 13 over 12. If you notice, these ratios are just going to be the inverses of each other if I just invert the numerator and the denominator, or reciprocal. So here, the secant of theta, so Cho was cosecant, hypotenuse over opposite, and then Sha, so the secant is the hypotenuse over the adjacent. So hypotenuse is 26, adjacent is 10. And then simplifying that, 26 divided by 2 is 13, 10 divided by 2 is 5. And then lastly, cotangent of theta. For cotangent, we do cow, so A, adjacent over opposite. And then the adjacent side from theta is 10. And then the opposite is 24. So we just do 10 over 24, which reduces to 5 over 12. So now moving on to another example here. I notice that I don't have all sides of the right triangle. So I'm gonna have to use the Pythagorean theorem. So I'm just gonna label here's A, and then here's B, and then here's C. So A squared, I have 9 squared plus B squared equals 14 squared. So 9 squared, 9 times 9 is 81, plus B squared equals, I'm going to grab a calculator for 14 squared. So clearing that out, 14 squared is 196. Now to solve for B, I'm going to subtract 81 from both sides. And then I get B squared is equal to 115. And then taking the square root of both sides, so B is equal to the square root of 115. So I'm just going to double check that and then just go, all right, well, 9 squared plus the square root of 115, close that parenthesis and then square it. And then that's 196, which should equal 14 squared. So if I take the square root of 196, I get back 14, so I didn't make a mistake. So now we need to identify the trig ratios from theta. So again, here is the opposite side. Here is the adjacent side. And then here is my hypotenuse. So again, for sine, cosine, and theta, so I have opposite over hypotenuse, adjacent over hypotenuse, and then TOA, opposite over adjacent. And then for cosecant, secant, and tangent, it's CHO, so hypotenuse over opposite. SHA, so secant is hypotenuse over adjacent. And then for cotangent, COW, adjacent over opposite. And what I'm going to do is just fill these in. So here, if I'm starting from theta, the opposite is the square root of 115 over the hypotenuse, which is 14. And then here, for the cosine of theta, we have the adjacent, which is 9, over the hypotenuse, which is 14. And then as I look here, there's no common factor to divide out between 9 and 14. And then the tangent, opposite over adjacent. So the opposite is the square root of 115 over 9. And then remembering for the other ones, we just do the reciprocal of both. So 14 over the square root of 115. I just flip that. And then here, same idea. Flip 14 over 9 over 14 to 14 over 9. And then here I can flip 9 over the square root of 115.